Well, good morning, good afternoon, good evening to everyone, wherever you may be, anywhere across the world. Thanks for joining us live here again today for Serverless Office Hours. And we're streaming on AWS Twitch channel and on Serverless YouTube and also recently on LinkedIn. So if you're joining us from any of those three, super cool to have you. Please send us your questions, send us your comments, do thumbs up, do likes. If you want to get notified about future episodes, please press subscribe on the Serverless Land YouTube channel or wherever, all the other kind of options, and then you can get all the cool new Serverless Land content. So, hello, my name is Julian Wood. I'm a Senior Developer Advocate for Serverless here at AWS. And this week, I'm super happy to be joined by an expert on all things AppSync, Brice Pellé, who also works at Amazon. And yeah, Brice, how are you today?
Doing good, Julian. Thank you very much for having me. Really happy to be here and excited to talk about all things AppSync and GraphQL.
No, absolutely. Brice, you've been, I think, in the AppSync team for sort of 7 or 8 months, but you've been at Amazon for 6 years, which I think in normal human years, like dog years, is going to be a long time. So, yeah, what else have you done at Amazon or AWS?
Yeah, so I've been at AWS for a while, just as you mentioned, and I guess that makes me one of the oldest tenured persons here at AWS. So I joined about 6 years, maybe I think in 2015, and initially I joined as a technical account manager in our enterprise support organization. And I came over from Ericsson, where I had done software development and technical sales, and I had been working in mobile radio access networks and mobile broadband. But I worked as a TAM for a while. I worked with a couple of telco customers, and after that, I actually joined our specialist organization as a mobile specialist. So I've been working with AppSync for a very long time before even joining the team, and then recently just made the decision to work even more closely with AppSync, and now I'm working as part of the product management team for the AppSync service team.
Fantastic. I love a long, interesting journey where you've done a whole bunch of different stuff. So yeah, just quickly, what I'm going to do is I'm just going to go through, what's been happening in the world of serverless over the past week, and then we'll come back and hear all of the goodness of Brice. So if you didn't catch us last week on the YouTube channel, we covered AWS Lambda, and Eric Johnson was your host, and we had Adam Wagner and Anihit Pogosova. And they went through all the new event source filtering for Lambda, where you can filter out event sources. And yeah, that was a super good show last week, so I encourage you to have a look. We're still looking back at reInvent and all the cool things that were happening. So from the serverless perspective, this is a link to all of the breakout sessions which are posted on, which are now posted on YouTube. I'm putting the link in the comment now, so you'd be able to link from that fairly easily. But yeah, a whole bunch of sessions which are available for your viewing after the fact. We also did Serverless Office Hours at reInvent live from the conference. So that was really good. We got to speak to some serverless heroes. We got to talk about Serverless Espresso, which is a great project we did. And really interesting, David Richardson, and he's the VP of Serverless at AWS. So yeah, a few levels above me, I can say, pretty head honcho, and it's really interesting to hear all of his thoughts and prognostications about what serverless is gonna be. And yeah, some more heroes, even Matt Coulter, who was on stage talking all about the CDK. And yeah, it was really great to talk to him. So that's also cool things to look back on reInvent and catch up on all the great content. There's also a blog post that my colleague James has put out. In case you missed a blog post, I'll post these links in a second, so you don't have to hunt them down. And this is basically everything that was happening in serverless in Q4 last year. I know it's already nearly the end of January, so things seem to be happening quickly. But yeah, this is a quick and easy way to catch up on all the things that were happening over the last quarter. And just new in AWS Serverless over the past week, well, Brice is going to talk a bit about this with some AppSync stuff, so I'm not going to steal his thunder at all. And then DynamoDB can return the throughput capacity consumed by GraphQL API calls, if that's of interest for you. And then, yeah, another thing on Lambda, an additional control for the max batching window. So this is some of the streaming and queuing event sources. So just being able to have some more control how often your Lambda functions and give you some more efficiency for your Lambda-based apps if you're using those services. In case you missed it, we covered a big thing for Node recently was top-level await and ES modules. So Dan Fox has done a really good blog post on explaining all of that. And yeah, just as we spoke about those batching controls for message broker services, Mitch and Malik has done a blog post on that. And then, not blowing my own thunder, but I've done a blog post which I posted recently. So Lambda functions can now run on the ARM-based Graviton 2 processors, and that whole blog post goes through all the ways that you can migrate it and how you can test and things to think about and some gotchas, and yeah, just helping you, why not, save some money with your Lambda functions by running them on Graviton 2. So I suggest you go and take a look. But this week, as I've said, is all about AWS AppSync and all the sort of cool new features. So Brice, I'm more than happy to head over to you. Can I share your screen?
Yeah, let's do it.
Excellent. Brice, tell me about GraphQL and AppSync.
Okay, more than happy to do so. Let me just double check again that my screen is visible here and that you're looking at the right stuff.
Okay. Is good. And just, yeah, of course, we're live on Serverless Office Hours, so please send us your questions, either via any of the channels. I can pop them up on screen. I can ask them, Brice, during the session. So please, send us all your questions, and we'd be happy to help. And if you like what Brice is saying, give him some thumbs up, and yeah, we'd love to hear from you and what you think.
Yeah, definitely. Let's have a conversation here. So I'm going to go over some material just to help people maybe get an understanding, maybe for folks that are not super familiar with what AppSync is, understand what it is, and then I'll dive into some of the features that we introduced over the last couple of weeks and share a couple of useful links in case you also want to get started with AppSync. So I think the first thing to do maybe is to explain what GraphQL is, because GraphQL is an important component of AppSync and what AppSync is. And a lot of times we talk to folks about GraphQL. It's a technology and a specification that's been growing really quickly, especially into mobile web app development space. But there are still quite a few people out there that don't know a ton about GraphQL. And it'd be interesting to see into comment and to chat if that's you, if this is your first time hearing about GraphQL, if you're interested in learning more about GraphQL, please let us know. But let's start by defining what GraphQL is. And I find that the easiest way to put it is just by kind of letting you know what the GraphQL documentation says about the language, about GraphQL. So GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. That's the kind of definition that you get if you go on graphql.org. And I like this definition because it underlines a couple of key things about GraphQL. The first thing is that it's a query language. Very important. Essentially, what GraphQL allows you to do is it lets you construct requests that pull data from multiple data sources in a single API. And it does that by allowing you to describe your data. It uses a schema definition language to do that. So you can describe your data where you define types, and in your types you define fields. And then with that data, now after you've defined that data, you can actually ask for what you want. And because you have an explicitly specified data type and model, you get predictable results. So you define your data, you ask for what you want, and you get predictable results. And there's a lot of advantages when you are using this type of system. So if we look at the query language part of GraphQL, a couple of key concepts, if you're really going to dive into it, or if you're just looking to get started, is that GraphQL is essentially allows you to define your data by using a schema. I talked about the fact that it has this SDL, schema definition language. And within the schema, you define types and you define operations. A type is very simple. You see an example of it here. I can define a model that represents a user. And in my type, I have fields. My fields are typed as well. So you can see that I have a username that's of type string. And you see the exclamation mark at the end there, which states that the username is a required field for a user. So if I want to create a user, I must have a username. And then it defines the operations that you use to interact with the data. So a query, as the name suggests, allows you to get data. Mutations allows you to mutate data. So create, update, and delete. And then GraphQL introduces a really interesting concept of subscriptions. Subscriptions essentially is an idea that you should be able to get real-time notifications of changes that are happening in your GraphQL system. So for clients that are connected, subscriptions allows them to get real-time notifications. That's pretty cool when you think about applications that are pretty chatty or need to get like low latency notifications. They can get that by simply implementing subscriptions. And I'll dive into how you can actually make that happen.
So Brice, just on those subscriptions, how, if
Yeah.
somebody's maybe used something like IoT Core or something like that for a front-end notification, how would people think between the difference between that approach and using AppSync?
Yeah. So with AppSync, when we talk about subscriptions, the key thing is we're talking about inline live notifications. So subscriptions apply for with AppSync to clients that are connected, right? So your client has to be connected to receive notifications. If something happens in your system and your client is not connected, we don't replay that data, or we don't automatically push that data to your clients. And then the other thing that we're doing here is we're using pure WebSockets to implement our subscription layer. So we're essentially just using regular WebSocket, which means that it's supported across a ton of other clients, right? So you set up your WebSocket and we send you the notification. And so this may differ with other systems, maybe some IoT systems that maybe use MQTT, or IoT systems that have some different levels of QoS and so on. So those are not, QoS is not a concept that we support within AppSync. And instead of using something like MQTT, which we used to use back into earlier on in AppSync, now we've actually moved to using WebSockets, which we think are a lot more efficient and provide a lot more flexibility and scale. And please, Julian, keep the questions coming. So query language for your API. This is what it looks like when you define queries, mutations, and subscriptions. The one thing to pay attention to here when we talked about getting the data that you want is looking at the selection set. This is something that really allows you to optimize how you interact with your AppSync, with your GraphQL API. So you can define a query and a query called getPost, and say, for example, what I want to get my ID to a post with ID 1. And here I can then specify the fields that I want to get back. And the cool thing about GraphQL is I don't have to get all of the data back. I can specify exactly the data that I want to get back. So depending on the use case that I'm implementing, I may not need to get everything back about a post. I may be on a mobile device that has limited real estate to work with. So there's really no need in getting all of that data back. So I can get the ID or title, or I can specify whatever I want. So that's kind of the flexibility, what allows you to get exactly the data that you want back. So a couple of things that you can do with GraphQL. You can reduce the number of requests because you can use a single API to query for multiple types of data. So you can, in a single request, you can fetch multiple types of data for different data sources. This then allows you to reduce and control the amount of data that you send back over to wire. So this can help with performance, cost, and even latency. It can also really offload your clients because they don't have to receive as much data as they would traditionally get. You receive the data in an expected shape and format, meaning that if I specify my selection set, I only get back what I specified in my selection set. So I don't need to do a lot of transformation and data manipulation at the client. I can really just focus on the job that I need to do. And this in turn reduces the onboarding overhead. Because the schema is explicitly typed, I don't have to second guess and try to figure out what I can actually access and what I can do with it. I can easily look at the schema and understand what it does, what I can request, and because I get the data into shape that I expected, it's easier to work with the data. And I can connect to multiple data sources, right? So this is, you having control over your data. So the cool thing, as you put together this API, you have your data sources and you build you do your data modeling to connect your data sources and make sure that the data is available for your clients. But your clients in turn don't really have to worry about the data source, right? Your front-end engineers, for example, don't have to become SQL expert or NoSQL experts or understand how to interact with a data lake. All they need to do is be able to make queries, and they will get the data that they need. So this is another advantage.
Yeah, I think that advantage is one of the biggest, really cool things, because it's so nice to be able to have a sort of clear distinction between the front end and the back end from your data perspective. So, reducing the number of requests and certainly the amount of data, but being able to collect multiple data sources. You can do migrations in the background, and so you can move data around, you can change the format and everything. As long as your GraphQL schema is amended within AppSync, your data can literally sit in a number of different places, and it sort of aggregates all together, and your front-end GraphQL API can still say simple. So, yeah, when I've seen that, I'm like, that turns the lights on for me.
Yeah, that's exactly right. And we have a ton of customers that are doing this, that are connecting data lakes, that are connecting like different type of data sources, and doing transformations and running pipelines within their GraphQL AppSync APIs. So we've seen some pretty interesting things from customers there. And then I talked about the real-time notifications. So the key thing here is with this real-time notifications with the subscriptions, there's no more polling. So there's no more need to tax your backend systems and consistently ask for data. Not only is this more efficient for your clients, but it also reduces the amount of load that you're putting on your backend systems by constantly sending requests for data changes. And when you think about it, it's like with one client, maybe that's not that much of a big deal. But when you're scaling to connect tens of thousands and maybe up to millions of clients, it really starts to have an impact, right? If you can reduce that polling and just have these subscriptions set up, it really helps offload the load on your data, on your backend services. So what we like to say is that with GraphQL, you get exactly the data that you need, nothing more, nothing less. That's kind of a quick, short way of describing what you're doing there. And then where AppSync comes in is, think about GraphQL. We talked about the fact that it's a query language, but you also need a runtime. So you can have that query language, but you need a runtime to fulfill those requests. And this is where AppSync comes in. So AppSync is a managed AWS service that makes it easy for developers to connect data sources in their API, right? And then it enables applications to easily interact with that data. So in short, you could say that AppSync is a data API that makes it really easy to connect applications to your data. And it does this by implementing GraphQL. So it's a data API, but it's also a managed GraphQL service. It goes beyond just the basics of GraphQL. It really just, I look at it as a data API because you're connecting all of your data sources, but it's able to deliver a lot of these functionalities because it actually implements a fully compliant GraphQL service by allowing you to configure GraphQL endpoints.
Thanks. Brice, can I just jump in? Because we do have a question, and Sonus from Twitch, thank you very much for watching. And I suppose the question's about, does AppSync scale as API gateway? Also, comparison-wise, does AppSync have parity with respect to all features of API gateway? I mean, I will say, these are different features, different products. This, AppSync is all about GraphQL, so it isn't API gateway, which is different. But how would you answer this, please?
Well, I think that's a good way of kind of answering that question, because there are different services that address different challenges. So it's not really an apple to apple comparison. It's more apple to oranges, right? What I like to tell customers is kind of think about the capabilities that you need, think about the functionalities that you need, and try to evaluate what service makes the most sense for your use case. I'll talk about some of the features that we have, but AppSync has a ton of security features, allows you to authenticate different type of user, to authorize different type of requests based on different mechanisms. It's a serverless service. That's one thing to remember, that it's serverless. There's no infrastructure to manage, and then it integrates with other serverless services really well. And I'll show a quick demo of that. But you should look at AppSync as an additional tool in your serverless arsenal, in your serverless toolbit that you should put to use when it makes the most sense. So I can't really give you an apple to apple comparison because there are different services, but I think both services have use cases where they work best.
Yeah, and I think the only thing I would add is I would think of API Gateway as a way more general API where you're not just handling data, but you can do post requests that can kick off whole asynchronous processes, for example. You can run Lambda functions that can, not necessarily just handle data, but can run processes or integrate with step functions or event bridge and create these whole workflows. While I think AppSync is, really focused on being a data API for, retrieving and creating data.
Yeah. Some other questions that I see here: how to secure schema with WAF. AppSync integrates directly with WAF, so you can simply integrate AppSync with WAF and use all of the rules that WAF has at its disposal with your AppSync API. Is it possible to subscribe to array of items but not one item? This is an interesting one. We actually have an RFC out for new capability that we called enhanced filtering. I'll put the link to that into chat. But we are looking at enhancing the way subscriptions work. So I would encourage you to take a look at that. I'll put the link into channel in a moment. So right now you cannot subscribe to an array of items, but take a look at this RFC that we have out on GitHub.
Excellent. Thanks, Andre, for your questions.
Yeah. Okay, let me move on real quick. Give me 1 second.
Yeah, I can see some other questions come in, but we'll let Brice get through some other kind of stuff, and we'll certainly come back to your questions.
Yeah, and stop me as we get them. Like I wasn't looking at the chat, and then I came back and saw a couple of questions. So as they come in, feel free to stop me. So how does AppSync work? Real quick, we talked about it being a data API. That means that you can really use it in a variety of use cases and scenarios. We are seeing customers and developers use AppSync to connect enterprise applications, web and mobile applications, real-time dashboard, IoT applications, and also implement offline applications. So the way it works is AppSync, like I said, allows you to connect to data sources. You can really connect to any data source, but out of the box, AppSync works with a couple of data sources and services in AWS. Amazon DynamoDB, Aurora, Serverless, Elasticsearch, and Lambda, to name a few. Amazon DynamoDB and Lambda are, some of our most used data sources with AppSync, and Lambda is definitely one of the favorites. We're seeing a lot of adoption of AppSync along with Lambda because of the close integration into capabilities that we offer. So within AppSync, you have your GraphQL API, and it starts with your schema. You start with data modeling, figuring out what you want to expose, what your client needs. When a request comes in, your request comes in asking for data, and you're trying to link that request to data sources. AppSync actually doesn't know how to do this by itself, right? So you actually have to provide the business logic that will resolve those queries into requests to your backend. This is what we call resolvers. This is the business logic that you provide so that AppSync can fetch data from your backend. And so this resolver business logic is written in VTL. Those are velocity template language. It's essentially a language that allows you to write templates that we can then evaluate to fetch data from your backend. That is one way of writing business logics with AppSync. We also support a concept of pipelines, and pipelines are really interesting when you want to interact with multiple data sources in a single request. We see a lot of customers doing this. If you have one request that comes in, but you need to fetch data from multiple data sources, you could do this with a single, what we call unit resolver, and kind of have nested resolvers. But you can also use a pipeline where you sequentially access data sources. So maybe you need to start by getting something from Aurora Serverless and then getting some additional data from DynamoDB and doing some transformation in your Lambda function. You can do that with a pipeline function, with a pipeline resolver. Speaking of resolvers, I talked about the fact that we have Lambda, and Lambda is one of our most appreciated integration with AppSync. We also give the option for developers to not write any VTL. You can write resolvers without writing a code of VTL by using what we call direct Lambda resolvers. With direct Lambda resolvers, you just tell AppSync to associate a field with a Lambda function, and then when a request comes in, we will automatically forward that request to your Lambda function. And then at this point, you use your Lambda function to run your business logic and to retrieve your data. And so this is one of the preferred ways that developers are using Lambda when they want to write really complex business logic, and then they have the choice of using the language that they prefer, whether that be JavaScript, Python, or something else. Recently, we introduced a new concept called, well, no, not a new concept, but we introduced a new functionality that lets you configure the batching size that you can send to your Lambda functions. To really explain what's going on here is, if you've worked with GraphQL for a while, you know that GraphQL has, deals with an issue called the 1+n problem. Because as we mentioned, with GraphQL, you can use a single query to access multiple data sources. So one thing that can happen with these type of queries is you start off with one request that then transforms into n additional requests to your backends. And if you do not handle these n additional requests in a smart way, these can end up being really expensive and really inefficient queries. A way to solve this issue is by doing batching. So when I have something like let's say I'm getting a list of posts, and for each post I'm getting a list of comments, right? The naive way of doing this would be to individually go get the list of comments for each post. But if I batch those requests, I can then create an efficient query, maybe to my SQL database, to get all of the posts that belong to all of these comments, right? That's what we're calling batching. So what we've introduced is the capability for you to specify the batching size. The default used to be 5, and now you can batch up to 2,000 requests in a single Lambda function. So it's a lot more efficient. We do a lot less calls to your Lambda function, and then in your Lambda function, you can write more efficient queries to get the data that you need. And we're already seeing a lot of adoption when it comes to this functionality. I think this is something that's really helping out customers. One of the quick things that I want to mention about AppSync is the security. I just love the security functionality that we have in AppSync, specifically to different authorization modes that AppSync supports. So one of the strengths of AppSync is that you can use it in a multitude of scenarios and to provide access to different type of users. And we do that by supporting multiple authorization modes. So we support API keys. If you want to use a simple API key to authorize your request, you can easily integrate AppSync with Cognito user pools. So if you've got users, or with any fully compliant OpenID Connect service. We also support IAM. So if you want to sign your request to AppSync using IAM, you can do this. And this is great for backend systems. So if you've got like a event-driven system that's calling a Lambda function that's mutating data in your AppSync API, you can simply use the permissions and associate it with that Lambda function to sign your request. And then we also introduced in the middle of last year custom authorizations using AWS Lambda. So if none of these other modes work for you, if you've got something really specific that you've implemented, you can use Lambda to actually authorize requests. So you will call your Lambda function for you, and then we'll cache the results. So it's really flexible. You can use any mode you need. And then the other key thing is that you can use all of these modes at the same time in a single API. So you don't have to deploy multiple APIs just to do one thing and to cater to different type of users. You can configure all these modes on the same API, and you can actually specify which part of the schema different modes have access to. So you may have something for your operators, for your administrators, that maybe only administrators can do mutations, and then you have your Cognito users that can do queries. You can do all that in a single API by adding the right directive to your schema. Okay, let me talk quickly about real-time. There are a lot of real-time use cases, and by real-time here, I'm talking about, again, providing real-time notifications in applications, right, without having to pull for data. Just think about all of the different applications that we interact with out there. A lot of these applications actually need this type of functionality. Dashboards, websites that provide updates on scores, right? Like if you go on like NBA.com or NFL.com or MLB.com, and you see the tickers, right? The breaking news. If you look at stock quotes, flight updates, even things like document collaboration, right? If you're jointly working on a document and you want to make sure that your partner is seeing your changes in real time, you need something that's going to send those updates as they occur. Chat is another one that we see. So there are a lot of real-time use cases out there, and these things are really hard to implement if you've got to implement them from scratch, right? And so AppSync as a real-time service makes it really easy to do that. You can use AppSync to broadcast real-time data. I talked about the fact that you can use an AWS Lambda function to mutate data in your AppSync API and then have that data propagated to your clients. So think about this event-driven system where you have EventBridge and Lambda working in conjunction to trigger events to your AppSync API, and then you are sending those events to your mobile clients, right? Really powerful stuff. And so I mentioned the fact that AppSync works with subscriptions to implement, works with WebSockets to implement subscriptions. So it's nothing proprietary, nothing, we're not inventing a new protocol here or a new way of connecting. We're using pure secure WebSockets. And the key thing here is that when you have an application, you only need to set up this one WebSocket, and then you're in this semi-consistent connected state. And now when a change occurs in your AppSync API, you automatically get that notification without having to reconnect or to poll for an update. And so with AppSync, that's it. Like I'll show you an example, but the subscription is so real-time functionality, and subscription is so easy to implement. You really don't have to do anything else. AppSync will take care of the connection management, the scale, fanning out, the broadcasting, and we publish a ton of metrics to let you know what is going on with your subscriptions and with your real-time implementation. It is really simple, and with a couple of lines of code, you can get this set up. So let me maybe start ending this by talking about our recent releases. So we've been quite busy over the last couple of weeks. So let me talk about the releases. We released custom domain names for AWS AppSync. This is a feature that allows you to use your own domain name. So it's essentially bring your own domain name to the party and use that with your AppSync API. So instead of using the default endpoint URL that we provide, right, that's a generic endpoint, you can use your own domain name like api.example.com and use that with your AppSync API. There's a ton of reason why you should use custom domain names if you are not using it already. With custom domain names, you set it up once, and then you can associate the domain name with any API in your account inter-region. So it makes it really easy to have a consistent endpoint that doesn't change, so you never have to update your clients. And then you can do blue-green type of deployments by testing an API, right? You take it to staging, and then you take it to production. And then when it's ready, you simply associate your custom domain name with this new API. So ton of benefits here. So I definitely encourage you to check that out. I already talked about configurable batching size for Lambda resolvers. That's pretty big as well. We released cache entry eviction. So AppSync provides AppSync level caching for your APIs. So this is a way of offloading your data, your backend data sources, and reducing the latency of requests. If you have really read-heavy systems, you don't always have to go to your backend data store. What we've done now is that we've made it easier for developers to evict entries, right? So if your data is changing, if you're doing a mutation that's going to change your data, and you want to make sure that that data is evicted because it's now stale, you can do this in your mutation by using some of the functionality that we provide. So this makes caching more it makes caching more available to more use cases, right? If you had a use case right now that required you to have like really tight control over like stale and fresh data, maybe that was hard to do before, but now with this feature, you can easily do that. Another neat thing that we released recently is a ULID utility for auto-generated IDs. So ULID is similar to UUIDs. They're unique unique identifiers, but they're unique identifiers that are always sortable by the time they were created, right? So this is an interesting feature to use if you want to store data, maybe let's say in DynamoDB, with an ID that are sortable based on the time that they were created. You can use that. So it's a pretty nifty tool to use if in the right situation, in the right use case. Okay, maybe let me stop there. Let me go back to the chat and see if we have any questions or any comments.
Yeah, certainly we'll go go through. I've never heard of ULID before, so yeah, that sounds great. Have a sortable UUID. Yeah, that's going to be super useful. I'm even thinking of bigger use cases where you have partition keys or that kind of thing, and you need to have some control of how that works. Okay, question-wise, let's just look at Parampreet. Thank you very much for your question. Yeah, any added latency performance overhead for GraphQL operations, vis-a-vis REST APIs?
I mean, it's really hard to say. I would say if you're connecting the same business logic and the same backend, probably not. But that's a really hard question to answer, right? It really depends on what you've got going on, what you've built. Then the other thing to remember is with GraphQL, you can have nested queries, right? With a REST API, you're asking for one thing, right? You have your URI, you're asking for that resource, you get that one thing. And typically it's fairly static. With AppSync and with GraphQL, you can have nested queries, so you can have a lot of execution going on there. So it's kind of hard to answer, but I would say best thing to do is kind of compare. An easy thing that you could try to do is take that business logic, whether it's a Lambda function or whatever, and use that same business logic in an AppSync API and see what you get.
Yeah, I mean, I don't think, if the question is also, is GraphQL going to add a whole lot of extra latency to my queries, then probably not. I mean, that's the more kind of thing. It's going to be more efficient. So yeah.
Yeah, AppSync is really. I mean, go take a look, but it's there's very low. I mean, there's always going to be overhead, like when you're processing business logic, but the AppSync service itself is pretty speedy, right? So these are not official metrics, but the main thing to say is that we're not really introducing latency at that layer.
Thanks, Parampreet. Yeah, Amit's one, I know you've covered some security things, but yeah, best way to secure public APIs from front-end frameworks like React, allow from whitelisted domains only.
Okay, let me see. Best way to secure public. Well, the key thing maybe is to assess your security posture and figure out how you want to authorize requests, and that's why we provide multiple different authorization modes, right? So maybe an API key is sufficient for what you want to do, right? Using an API key, typically the way that works is your API key is hard-coded in your code, and you're using that API key to access the API. Okay, so what that means is that in that use case, you're okay with anybody accessing your API as long as they have the API key. And if you've deployed a web application, that's kind of the use case. But maybe that's not enough, right? Maybe you need more control over who has access. And in those cases, you should think about using either a custom Lambda resolver or using something like Cognito if you're using a user-based application where you have users logging in, right? And then the other thing is as you evaluate your security posture, think about using something like WAF, right? Because you can implement the right rules, like you talked about domains and
you can add your own custom rules to WAF for your own business, not just a generic thing.
Yeah, definitely.
Excellent. Well, thanks for the question. Yeah, Bala. So from a serverless design, recommendation to use AppSync within the boundary of a service or across service boundaries.
From a service, what is the recommendation? Use AppSync within the boundary of a
I would
service.
just start
off. What do you think here? I'm trying to understand the question, but yeah, go ahead.
I mean, if you're thinking of AppSync as an API, then that is a sort of bounded context. But then your AppSync is then going to talk to other data, which may be across other kind of services. So I think if your API is going to be the front door, that is going to be a good bounded context for that data. But I suppose the more backends you then go and collect data from, that would be more coupling. So you've got to decide how you want to do that. But yeah, anytime if you've got a data specific API, this is going to be a good use case to have at least a single point you can connect to across boundaries.
Yeah. And then the other thing to remember is, we take security very seriously. So anytime AppSync interacts with a data source, AppSync is only doing that because you've granted it the specific permissions to access that data source, right? I think that's also one of the other advantages, right? You can really reduce your attack footprint by providing this one entry point, which is your API, and you've got the right access controls at that level. And then in the backend, you've also got a different set of permissions that has nothing to do with the original user that's making the request. You're not controlling whether or not AppSync can access that data by using IAM permissions. The other thing to keep in mind is that even within those resolvers, right, you also have access to your own authorization rules, right? You can check, for example, if a Cognito user is part of a certain group, or if a Cognito user is has custom attributes or whatnot. So there's some additional security stuff that you can do there as well. But yeah, AppSync kind of allows you to decouple, right, these different layers and apply different security rules at the different levels.
Excellent. Yeah. Thanks for the question. I know Brice also wants to get to a demo to show, so we're gonna speed up some of the questions. We do appreciate them, but we also want to show all the stuff. Yeah, so Igor, thanks for watching. Can I receive data from AppSync in the same order as the data sent? So it's a mouse event with WebSockets and API gateway Lambda haven't the same order sent and received. I'm not quite entirely sure how that is, but his example is saying if I send data 1, 2, 3, 4, I can get receive 1, 2, 3, 4 in this order.
No, so we do not guarantee in order delivery.
Okay. That's fine. That's good to know. Jamie on LinkedIn, thank you for watching. We're able to get 3 fields of single endpoint response from 3 different Lambda for single endpoint for AppSync Lambda Resolver case. Right. I'm not entirely sure.
Yes, yeah, you can. Okay. Are we able to get 3 fields of a single endpoint response from 3 different? Yeah, definitely. Yeah. You can have 3 fields associated to 3 different Lambda functions, and then request those 3 fields, and we will evaluate those 3 Lambda functions as the request comes in. Yeah, you can do that.
Perfect. Thank you, Jamie. Sonus again. API gateway time under 30 seconds. Does AppSync have a similar timeout?
Yes. I can't remember off the top of my head, but yes, we have a similar timeout, and I do believe it's 30 seconds. I'll point you to the documentation for that, but I believe the answer is yes here.
Okay, thanks. And yeah, just last one for now. Zach Jones Noel, thanks on Twitch. Custom domains, do they work well with WAF?
Yes, same functionality. The key thing here is with custom domains, you are getting all of the functionality that you get with the default APIs. The other thing to mention is that with custom domains, another advantage, which is actually a key one, is if you've used AppSync and you've used the real-time component of AppSync, you've seen that we provide 2 different endpoints for your queries and for your real-time. When you use custom domains, you only have a single endpoint. So it actually simplifies things quite a bit. And if you need to, do allow listing, like we've got some customers in the public sector space that need to, get their APIs allow listed with their different customers, it actually makes it easier to do that, because now not only can you provide your own domain that your customer probably already has, but there's only one domain to add to the allow list. So, yeah.
Excellent. Thank you very much. Well, yeah, let's thank you for the questions. Appreciate them all. Brice, over to you again.
Okay, let me try to. I'm going to share another screen here. So just give me a second. I need to get things figured out. How can I? Okay, bear with me 1 second. I just need to change the source. Share. Okay, I'm gonna have to stop for a second, but I'll be right back. Share. Okay, let's start with. I think I'm gonna share my entire screen. It'll probably be easier because I've got a couple of windows to show. So let me go down here. Okay. All right. So what I'm gonna do is give you, like, if you're looking to get started with AppSync, there's a couple of ways that you can do this. You can use You can use the SAM CLI if you wanted to do that. You could use Amplify. You can go into the console. You can use CloudFormation. You can essentially use whatever tooling you want. But one of the ways that a lot of developers are interacting with AppSync when it comes to deploying it is by using the CDK. So the CDK is really nifty and provides a lot of cool features to easily build an AppSync API. So I'll just kind of show you how you can go about building an AppSync API using the CDK, and then I'll go over some of the functionality. So it's really simple to get started. So if you're not familiar with CDK, CDK essentially allows you to use your favorite programming language to define your infrastructure as code. Here I'm using TypeScript, and I'm using some of the level 2 constructs to build my API. So it's constructs that makes it a bit easier to build my API. So what I'm doing here is, as the name suggests, is I'm building a chat stack, right? Very simple demo. So let's say I wanted to build an API, a GraphQL API. How do I go about doing this? Well, in CDK, it's really simple. I import the AWS AppSync library. I use the GraphQL API construct. I name it. I provide my schema, and then I specify my authorization mode. As I mentioned, AppSync supports multiple configuration modes. Here, I'm going to go with API key. I can enable X-ray just by saying X-ray enable true, and I can set my log configuration settings. So here I'm saying I want to see all the logs, make it verbose, and the field log level should be all. And that's it. A couple of lines of code, and I've got an AppSync API. Literally, that's it. And then I've got it associated with a schema. So if I look at the schema, again, the schema is where I'm doing my modeling. I'm kind of defining how I want to interact with data. If you look at the schema, the main thing to focus on is I'm building a chat system, so I'm going to have multiple chats, right? A chat is made up of an ID and a name, some metadata like created that and updated that. And for each chat, I should be able to retrieve a list of messages. And a message is simply a type that belongs to a chat. So you have a chat ID here, and then the text that you send into message. That's kind of it. And then to connect my messages to my chat, I have a message connection here. What the message connection, it's nothing specific, or there's nothing special about this type, but using this type of definition allows me to retrieve multiple messages, and I'm going to use DynamoDB to retrieve the messages. So if there's a lot of messages, DynamoDB will send me the last evaluated key, which here is my next token. Right. So this is my schema. There's a couple more things here, but let's look at this for now, right? So if I go back to my stack, I get my API. That's it. Now I want to associate this API with a DynamoDB table. Well, then I can go in CDK and quickly create a table. I have two types, but I want to use a single table. So I'm going to use a single table design here with DynamoDB. And I configure my table. I call it's a chat table. I have a partition key. I'm going to use generic names. So I have PK and SK, right, for my partition key and my sort key. I really love using the CDK because it's so simple to define serverless constructs. It's almost a cheat code. And then the next thing I want to do, I've got my API, I've got my table. Now I connect the API to the table, right? And I do this by simply calling API at DynamoDB data source, right? And I specify the table. And then what this will do is it will create a data source in my AppSync service, and it will also configure the permissions, right? I talked about the fact that AppSync only does what you tell it to do. So it will specify the permissions to interact with the table. And then I create my resolvers. So there's a couple of things that I want to be able to do. I want to be able to create a chat. I talked about that. I want to be able to create a message. I want to be able to get a chat, and then I want to be able to get more chat. So what I'm doing here is I'm essentially associating these resolvers with my data source. So all of these things are saying create resolvers that will get data from my DynamoDB table. And then I have my code here as well in my project. You can see that I have all of my resolvers here. And I'm not going to go into the specific of each resolver. They're written in VTL, but we have a ton of examples of this. I actually wrote a blog not too long ago that talks about enhanced applications using single table design with DynamoDB for AppSync, which we'll point to. But just know that I'm using VTL here, and my VTL is essentially allowing me to interact with DynamoDB. So, for example, here I'm creating an object that will do a put item operation, and I can specify my key, I can specify to attributes, and I can specify to conditions. So a lot of people are not super familiar with VTL, but I think that when you're dealing with DynamoDB when it comes to AppSync, VTL is probably a good choice. It's interacting with DynamoDB is fairly straightforward if you know, I guess, what you're doing. But the VTL maps essentially directly to what, if you're familiar with DynamoDB, it just allows you to create an operation. That's all it is. So there's really low overhead. It's very straightforward. So if you're just kind of doing basic CRUD type of operations with DynamoDB, I encourage you to use VTL. If it's getting more complex, maybe you can use Lambda. Okay, so I define all of those resolvers, and that's it for now. Then I can do a CDK deploy, and this deploys all of my infrastructure. So this is my infrastructure. It's reproducible, it's testable, very easy to set up. So let's look at what that looks like in the console. Going to go in my console here. I'm in my It's a Chat AppSync API. So the AppSync console provides a queries editor that you can use to easily interact with your schema. One thing to keep in mind is when we're talking about AppSync and GraphQL, I think Julian mentioned this a while back, but for example, API Gateway is a generic REST API service, in terms of the API that it provides. But GraphQL is in our implementation in AppSync is also built on top of REST. So there's nothing really special about interacting with a GraphQL API. You're doing it over REST. You just need to know how to do it. So this queries editor here is just helping me send those requests. But you could use Postman to do the exact same thing. And I will actually show you an example in Postman, right? So the query editor makes it really easy to interact with your data, but you can use any client you want as long as you can send an HTTP request. So the first thing I'm going to do is I'm going to create a chat. Let's just see how this works. I say live demo, don't fail me. I want to see the ID. I want to see the name to update it at. Okay, and you see it's very, very simple. Live demo, don't fail me. And now if I wanted to see this, I can go to my DynamoDB table. This is the table associated with it. And then you see I've got a couple of things here from testing this before, but you see I've got my item here. So all this did was take my request and put it in this DynamoDB table. And you see that I've got my primary key, my secondary key, and I've got all of my data there. I can easily query and get the data. So I can get the chat. Let's use the ID actually. ID, created that, name, updated that. And I'll just do my query. And you see that I'm getting this back. So now that I've got my chat, I want to, create a message. I want to create a message in that chat. So I can come in here again. I specify to chat ID, and I say, this is my first message. And then get me the chat ID, get me all of these fields. And I do this, and then I can see this is my first message. Now, the cool thing here, when we talk about the fact that you can connect different data types, is in my get chat request that I have here, I can expand this and say, well, give me all of the messages items that are associated with this chat, right? And so I can do this here and then just do my query. And then now you see that I've got my chat, but I also have the message. And maybe to make this more clear, I'll add the text. And you see that I have my ID. This is a standard UUID. And you see that I've got another ID here. This is a ULID. So this is, I can actually sort by this. And this is actually what I'm doing. So anytime I get my messages, they'll be in a sorted order because they're using a ULID, right? This is the secondary, this is the sort key that I'm using, but they will be in order. So I can do this again, send another message, do another mutation, and then I do fetch it again, and you see I get my other message here. So really easy to do, right?
It's so nice that you can do these queries and test them out in the console really
Yeah.
easy before you've even connected your front end or done any of your proper client-facing queries.
Yeah, exactly. And you can do this here. I'm not gonna, like, you could do this in Postman as well. Like, so I already got this set up. But again, just to show you that this is just a request that I'm doing. I'll press send here, and you'll see that I'm getting this. Let me do the exact same request that I was doing here. I can copy all this, go in Postman. Actually, I want to paste it here.
And this is because, as you say, it's basically behind a REST API anyway. So
yeah,
it just happens
exactly.
to be in a format.
Yeah, exactly. So if you look at the curl equivalent of what I just did, right, you can see it here, right? So this is one of the cool things about Postman. I can come in here and kind of see, okay, well, what was the curl equivalent? What was, you know, the HTTP equivalent? So because it's a REST endpoint, you can interact with all of these things. Let me show you how subscriptions work, and then I'll
Brice, we've probably got a minute if you can squeeze that in.
Okay.
Let's give it a go if you can.
Let's see. You stop me. Can I do it? Can I be super quick? All right. We want to see how subscriptions work. I did not write a single line of code for subscriptions. Subscriptions work out of the box. There's nothing that you've got to do to make this work. I'm going to say that I want to subscribe to all of the messages that are coming from a specific chat. Delete this. I turn on my subscription here, and I'm going to go in my other console. I'm going to put it right here, put this here, put this here, close this, and close this, and I'm going to do a mutation. I'm going to do a mutation. Okay, I need to be quick. Create chat, create message. Okay, and so I'm going to send this. I'm doing this super quickly, but I'm sending this mutation, and you can see that I sent something
amazing.
on this screen, and I'm seeing something right away on this screen. I did not write a single line of code. I didn't write anything specific in my schema. All I did in my schema is write this, and then we'll end it on this. Sorry, I'm going through this quickly. All I did is create a type, say subscription, on create message, and subscribe to these mutations for create message. That was it. I didn't have to write a single line of VTL or anything to make this happen.
Brice, you are a hero. You've been pushed under the clock. In a minute or two, you've shown the subscriptions. I love how simple this is. I think, you know, if anybody is looking at data and wanting to connect data from multiple sources, AppSync is, you know, one of the obvious services to look at, and you've explained it all super well. So, Brice, I super appreciate your time. It's been amazing to have you on Serverless Office Hours. You're welcome back at any time, of course, and I'm sure we'll be able to get into more AppSync things later on. So yeah, before we go, next week we're going to be talking about Amazon EventBridge. I've got a super cool guest lined up who's going to be talking about a whole bunch of new tools. So that's going to be super exciting. I'm just confirming that before I can do it publicly. And also remember, if you want any information on serverless or anything serverless, there's serverlessland.com. And actually flick on quickly the Serverless Patterns collection. If you're doing CDK, if you're doing SAM, there are AppSync queries in this as well. So serverlesspatterns.com is a really useful tool to be able to get all the information you need. Time is running out. Brice, you've been amazing. Thanks so much for joining us to talk all about AppSync. And yeah, please get in contact with us if you have any questions about serverless or AppSync in particular. And Brice and myself would be happy to help. Thank you very much. Enjoy the rest of your day.